In chapter 7, motion in a circle, we have new equations introduced that we're going to look at in a minute. Quick bit of revision. If we take a circle with a radius of 1, we know that the length of the arc, the distance around the outside of the circle, 2 pi r, which in this case will be 2 pi times 1, or just 2 pi, and we'll take pi as 3.14. The length of the arc of radius 1 is 6.28, and we'll take this in centimeters. We also know from the formula booklet that the length of an arc is equal to r times theta, where theta is in radians. So if we look here, the length of our arc is 2 pi, or that's going to be equal to r theta. If r is equal to 1, we're going to get 2 pi is equal to theta, so the length of the arc will be 2 pi, the angle will be 2 pi, and 2 pi is equal to 360 degrees, so pi is equal to 180 degrees. So we have 2 pi radians all the way around the outside of the circle, and we also have 6.28 centimeters. So let's look at the intro questions into this chapter. So they're giving us the same circle, and we're just asked to find in radians the angle. So we have here a circle with a radius of 20 from the question, 20 centimeters. The length of the arc is equal to r theta. So if we're looking for in radians the angle, we want theta is equal to the length of the arc over the radius. And we're subtended by arcs of length here, 40 centimeters. Theta will be equal to 40 divided by 20. So theta will be equal to 2 radians. Theta, if the arc length is 100, will be 100 over 20, which will be 5. I'll just leave it at 5. I won't write radians every time. And the third one, theta will be equal to the arc length 15 divided by 20, which is equal to 3/4 or 0.75 radians. And for the last one, theta will be equal to 11 over the radius 20, which is equal to 0.55 radians. Now, in terms of degrees, what's 1 radian in degrees? So if we take our 2 pi radians, is equal to 360 degrees. Therefore, pi radians is equal to 360 over 2, which is equal to 180. And if we just want 1 radian, put a 1 here, we're going to get 1 radian is equal to 180 over pi, which approximates to about 57.3 degrees. So let's have a look at some more questions here. So question 2, we have a circle of radius 5. Just do a quick sketch. We have my 5. We're looking for the length of arcs this time. Write down your formula. Starts off the easy one. L is equal to r theta. So we want the length of the arc. So we have 5 times 3. So the length of the arc is 15. The second one, we're going to get 5 by 0.8, which is equal to 4. And these are all in centimeters. Then we have 5 by 1.2, 6 centimeters, and 5 by 1.7 is going to be 8.5 centimeters. Just a nice easy start to these questions. Question 3, we have a circle of radius r. We're looking for the value of r. The length of the arc is equal to r theta. So r is equal to the length of the arc divided by theta in radians. So we have an angle of 3.5 radians, and we have the length of the arc is 14. 14 divided by 3.5 is going to give me a radius of 4 centimeters. And if we have an angle of 1.8 radians and the arc is 2.07, again the radius is going to be the length of the arc divided by theta in radians, and we have 2.07 divided by 1.8, and this is equal to 1.15 centimeters. So take this definition down. Angular speed, the number of radians completed in 1 second. If we imagine we have a circle and we have a speck of dust or a record player, it's going anti-clockwise in this direction. How many radians it completes in 1 second is W, the angular speed. So let's look at the question. First question on angular speed. The formula required for this is speed. This is linear speed v, which you've seen before, is equal to the angular speed by the radius. So question 5, we're given radius of 10 and speed v of the particle 18. So the speed of the particle 18 is equal to the angular speed times the radius of 10. So the angular speed for number 5 is going to be 18 divided by 10, 1.8. And that would be centimeters a second. And in number 6, we're given a particle moving with angular speed 4 radians a second. Its velocity is 7, find the radius. So 7, the velocity, is equal to the angular speed of 4 times the radius. So the radius is equal to 7 over 4, or 1.75 centimeters. Question 7, we have a single, which is a vinyl record from your grandfather's collection. Well, it could be your collection. Vinyl's coming back in. It completes 45 revolutions per minute. So 45 full turns in 1 minute 60 seconds. So we want in 1 second. 1 second will be 45 over 60. So 0.75 turns or revolutions in 1 second. We want the angular speed correct 1 decimal place. So if this is the record, if it goes from here all the way back around, it goes a distance of 2 pi. So it's going 0.75, it's going 3/4 of the way around, so 3/4 of 2 pi is 1.5 pi. 1.5 by 3.14 is 7. 3.14 and 1.57 is 4.71. 4.71. Correct, the 1 dp is 4.7. And that will be radians per second. In question 8, we have a bicycle wheel rotating, angular speed 10 radians a second. So my W is equal to 10 radians a second. Find to the nearest integer the number of revolutions completed per minute. If the radius of the wheel is 40 centimeters, find the speed of the bicycle. Okay, so number of revolutions, it goes 10 in a second, so 10 by 60 is equal to 600 in a minute. And 1 full revolution from here all the way around and back to here is 2 pi. So 600 divided by 2 pi will be the amount of full revolutions, and to the nearest integer this is working out to be 95. And then if the radius is 40 centimeter, find the speed of the bike. The speed v is equal to the angular speed by the radius. And presuming they want the speed in meters a second, we take set 40 centimeters to be 0.4. So the speed is equal to 10 by 0.4, which is equal to 4 meters a second. And number 9, when a CD is spinning at 200 rotations per minute, what's the angular speed in radians a second? So 200 rotations per minute is 200 by 2 pi radians per minute. We want the speed in radians per second, so we divide by 60. Straightforward enough for number 9. Doesn't ask for decimals. 20.94 radians in 1 second for number 9. So 570 revolutions per minute for number 10 for the DVD. Each revolution is 2 pi radians. What's the linear speed? 6 centimeters in meters per second, so that's 0.06. So let's have a look at the radians per second. 570 times 2 pi divided by 60 is 59.66 radians a second. And we want the speed, we want linear speed. V is equal to the angular speed by the radius. So 59.66 by 0.06 is the linear speed, which works out to be 3.58 meters, 579, actually it was a 579, we'll go 58 meters a second.